I'm going to do one of each type of problem. So here we're finding the solution to a system of equations. It doesn't tell me what method to use. Remember, we used elimination and substitution to algebraically solve these. Just looking at this, I'm going to say elimination is going to be the best route because I can't easily solve for one of the variables. Now, if you take a look, I can't just eliminate one of the variables, either x or y, because none of them are equal and opposite, but I can multiply this top one by 2 in order to get negative 6x. So I'm going to put my new function down here, but again, it's related to this top one that I'm multiplying all the factors by 2. So negative 3x times 2 is negative 6x. 8y times 2 is 16y. And negative 5 times negative 2 is negative 10. So now I'm going to add the two functions together. We're not worried about this one anymore. 6x minus 6x is 0. 2y plus 16y is 18y. Negative 8 minus negative 10 is negative 18. So y is equal to negative 1. But I'm not done. I need to figure out what x is. So I'm going to take this negative 1 for y, and I'm going to plug it back into one of the original equations. So we'll just choose this one right here. So I'm going to do 6x plus 2 times negative 1. So I'm plugging in negative 1 for y is equal to negative 8. So then we can do 6x minus 2, because 2 times negative 1 is negative 2, is equal to negative 8. I'm going to add 2 to both sides. So 6x is equal to negative 6. So x is also equal to negative 1. So our solution is negative 1, negative 1. And that's going to be my answer. Okay, so for number 6, they're telling me specifically to use substitution, so that must be the easiest way to do it. And it is, because they already solved for x for me. So basically what I can do is take this value for x and plug it into the other equation. So let's do that. So 2 times negative 4y plus 6 plus 9y is equal to 16. I'm going to distribute. So negative 8y plus 12 plus 9y is equal to 16. I'm going to combine like terms. Negative 8y plus 9y is 1y, so I'll just call it y plus 12 is equal to 16. Subtract 12 on each side, and I get y is equal to 4. Now I have to figure out what x is, so I'm going to take this y value that I just figured out, and I'm going to plug it in for this equation to figure out x. So x is equal to negative 4 times 4 plus 6. So that's negative 16 plus 6. So x is equal to negative 10. So my answer would be negative 10, 4. Okay, this is number 16. I'll do a couple of these because this is kind of new. So we have two inequalities, so we have to solve this system of inequalities. So remember, that's where our shading overlaps. So this top one I'll do in pink, and the bottom one I'll do in, let's do blue. Okay, so the top one, my y-intercept is 8. So I'm going to put a point at 0, 8. And my slope is negative 3/4. So I'm going to move down 4 to the right 3. Now, because it's just y is less than and not less than or equal to, I'm going to put a dashed line in. I'm going to go all the way. Okay. So that's my first boundary line. The second one, my y-intercept is positive 3, so I'm going to put a point at 0, positive 3. And my slope is 1/2, so I'm going to go up 1 over 2, up 1 over 2. And because it's greater than or equal to, I'm going to use a solid line for this. Okay, now we have to do our shading. So for the pink line, because its y is less than, basically every point below this boundary line, every point below the pink boundary line would be included in this inequality. So I would shade below the pink. And because for the blue one, its y is greater than, every line or every point above the boundary line would be included. So if we look at where does it overlap if I'm drawing below the pink and above the blue, it would be in this region right here. So that's the region that I'm going to do my shading. And that would be our solution. Now they ask for a coordinate, the coordinates of a point in the solution set. Basically what you could do for that is just choose any point in your shading. So I'm just going to randomly choose a point. That point would be in our solution set. So I could do -2, so -2 and 5 would be in our solution set. It's not the only solution, and I just chose a random point in here. Okay, let's do one more. All right, I'll do pink and blue again. So this one we'll do in pink. This one we'll do in blue. So the first one, I have a y-intercept of +8. So we'll draw a point at 0, 8. And my slope is -1, 2. So I'm going to go down 1 over 2. Because it's just y is greater than, I'm going to use a dashed line. The second one, y is greater than 3/2 x minus 4. So my y-intercept is at -4. And my slope is up 3 over 2. And I'm going to use a dashed line because it's just y is greater than. So we'll go all the way with that. Now for the pink line, we're going to shade everything above it because its y is greater than. So all of these values above that boundary line would be included. Same for the blue line. Everything above the boundary line would be included. So our area of overlap, where we're above the pink and above the blue, would be in this region right here. So that's what we're going to shade. Okay, so let's do the word problems. The word problems here, you're going to have to write 2 equations, because remember, we're looking at systems of equations. So here we have a songwriter who's collecting royalties on songs when they're played in a commercial or movie. So she'll earn $30 for every song in a commercial and $100 in every song in a movie. So let's say X is going to be commercial and Y is going to be a movie. Okay, so they say that her songs were played on 3 more commercials than movies, and her total earnings from all the commercials and movie was $610. Okay, so the first one to write is easier. So I'm doing 30 for every commercial. I'm doing 100 for every movie. And I'm making in total $610. So 30x plus 100y is equal to 610. So $30 per commercial, $100 per movie, gives me a total of $610. Now it also tells me that her songs were played on 3 more commercials than movies. So if I put movies, I can figure that the number of commercials that it played on, the number of movies was 3 less than that. So I can just do y equals x minus 3. So it's commercials minus 3 would be the number of movies. How would we solve this system that we just came up with? Well, substitution would be the best way because I already know what y equals. So I can write 30x plus 100 times y minus 3 is equal to 610. And now we just do the algebra. Sorry, it's x minus 3. Something didn't seem right. There we go. Okay, so I can do 30x plus, I'm going to distribute this 100. 100x minus 300 equals 610. I'm going to combine like terms and get 130x minus 300 equals 610. I'm going to add 300 to each side. So 130x is equal to 910. And I divide 910 by 130, and so we get x is equal to 7. And then we can figure out y by plugging in x is 7 to the y equation. So y is equal to 7 minus 3, which is equal to 4. So our final answer would be 7 commercials and 4 movies. Okay, here we have dry cleaners, and there's Pedro and Shin, and they're ironing shirts. Okay, Pedro can iron 10 shirts per hour. So we'll do x is equal to Pedro shirts per hour. Well, hold on. It's just going to be Pedro's hours. And y is going to be Shin's hours. And so Pedro can iron 10 shirts per hour, so 10x. And Shin can iron 30 per hour, so 30y. And they can do 310 shirts total, is equal to 310. They work a combined 13 hours, so that's easy enough. We just do x plus y is equal to 13. And now we just have to solve this system. So I'm going to use substitution because I can easily solve for one of these variables. So I can do y is equal to 13 minus x if I just subtract x on both sides of this equation. And I'm going to take that y value and I'm going to plug it in to the other equation. So I can do 10x plus 30 times 13 minus x is equal to 310. We'll do some distribution. So 10x plus 30 times 13 is 390. Minus 30x is equal to 310. I'll combine like terms. So I get negative 20x is equal to, if I subtract 390 on both sides, I get negative 80. So x is equal to 4. And then I can plug that 4 back up into my y equals. So I can do y equals 13 minus 4, so it's equal to 9. So in order to get 310 shirts ironed, Pedro would iron 4 shirts, or for 4 hours, and Shin would iron for 9. All right, I'm going to do one more. So Joshua is doing a farm stand that sells grapes and blueberries. Grapes are $2 a pound. So we'll do x is equal to pounds of grapes. And y is going to be pounds of blueberries. So he made $120. So it's $2 for grapes, so 2x, and $1 for blueberries, so I can do 2x plus 1y, so I'll just say y is equal to 120, and that he sold a total of 79 pounds. So x plus y is equal to 79. So determine the number of pounds of grapes and blueberries sold. So substitution is, again, the easiest way to do this. So I'm going to solve for y here. You can solve for x if you want. I'm solving for y. So y is equal to 79 minus x because I subtracted x on both sides. Now I can take this y value and plug it into my first equation. So 2x plus 79 minus x. You can put it in parentheses to start, but with the associative property, you can just drop those parentheses, and that is equal to 120. So I can combine like terms. So 2x minus x is just 1x. So x plus 79 equals 120. I'll subtract 79 on both sides. 120 minus 79 is 41. So x is equal to 41. And then to solve for y, we just plug back into this equation right here. So y is equal to, 79 minus 41, which is 38. So that means that there were 38 pounds of blueberries and 41 pounds of grapes sold. All right, I'm going to leave it at that. I think I did at least one of every type of problem, so you can take a look at this.